Today we will be factoring trinomials, and this is the third day we're factoring trinomials in a form that we've seen before. It's ax squared plus or minus the bx term, and this time, day one we had a positive c term, and the day two we had a negative c term. Today we are going to have both positive c terms and negative c terms. So if you look at the problems, we have the first three problems all have a positive c term. So the 24 is positive, 6 is positive, 20 is positive. The last three problems have a negative c term. And so that's the important part that I always look at when I'm trying to factor a trinomial. And so let's take a look at why we look at that. And we've mentioned it in the last couple of days, so let's see if we remember. When that's a positive 20, that tells us that we have the same sign. So if we have the same sign, what that means is that we're going to end up adding the outside terms and inside terms. Now, what are they going to make? Well, they always make the middle term, a negative 19x in this case. So what that means, if they're adding to make a negative, that means we know both signs. We know both signs both have to be negative. So the first thing we're going to do is draw our parentheses, and we can put in two minus signs in between where the terms will go. We also know that since we have a prime number right here, 3 is prime, we can start off with that term. And so first thing I'm going to write after the minus signs is a 3x and an x as the first terms in each binomial. So from this point, now we need to think of what two outside terms and inside terms will end up adding to make a negative 19x, but the last terms need to multiply to make 20. So what we do is we just try different numbers that multiply to make 20. And so we might try a 4 and a 5. If that doesn't work, we'll try a 5 and a 4. And then we also have a 2 and a 10, a 10 and a 2. And if those don't work, then we also have 20 and 1, and 1 and 20. So we've got all these different options that multiply to make 20, but only one will end up working if this can factor. And so let's try one of them. Let's try the 4 and the 5 here. And we'll check those inside terms. Those make negative 4x. The outside terms make a negative 15x. And sure enough, those do add to make that negative 19x. So it works. So the key is to look at that last digit sign, and if it's a positive, that means we have the same sign. The outside and inside terms are adding to make the middle term. So that's what we write in our answer boxes, just that 3x minus 4 and the x minus 5. Well, taking a look at the next one, we have a 5x squared plus 13x plus 6. So again, this sign right here tells us that the outside terms and inside terms are adding together, but this time they're making a positive 13x, so we know the sign. We know the sign inside the binomials is going to be a plus sign. So we start off with that 5x and x. Those are the numbers that make 5x squared. And then we just try different numbers that make 6. And so we're trying to think of like maybe a 2 and a 3, a 3 and a 2. Those numbers multiply to make 6. But we also have a 1 and 6 and 6 and 1. And so we just try those different numbers in these different locations. And we see which one of them, where the outside terms and inside terms add to make 13x. So when I first try here, I got 2x for the inside, 15x for the outside. Well, these add to make 17, not 13. So then we know we've made an error. And so what we can do is erase what we did there, but then it's important to cross off what you've tried. So we've tried the 2 and the 3. Let's try the 3 and the 2. Let's put 3 here, 2 here, and see if this makes a difference. So the inside make 3x, outside make 10x, and those do add to make 13x, which is what we wanted. And so we got it on the second try. So this factoring technique takes time. There is strategy involved in it, looking at like the outside terms and inside terms and seeing if they add or subtract. But also we can look at those terms and see, does it make sense that we're multiplying a 5 by a number to get a value that's 13? Remember, the outside terms and inside terms are adding to make 13. That means they both need to be smaller than 13. So using a 6 times by 5 is going to make something bigger than what we needed. So there is strategy involved, but there is a lot of guesswork too. So you just got to try different options until they work. Let's take a look at this one here. We've got a plus sign. Again, that means that we're going to end up adding the outside and inside terms. When we do so, we get a negative 17x. So what we know right away is that both signs are negative. So we fill in those signs and try the different numbers that make 24. But before we do that, let's fill in the numbers that make 3x squared, which should just be 3x and x. So let's go ahead and try those numbers that make 24. Remember, we only have a few of them. We've got a 3 and an 8, we've got an 8 and a 3, but we also have some others. So we said 3 and 8, 8 and 3, and we had 4 and 6, 6 and 4. We also have 2 and 12, 12 and 2, got 1 and 24, 24 and 1. So lots of different options that we can try, and you just got to try them all. So I'm going to try this first one, put the 8 here and the 3 here, and check those outside terms. Here I get 9x, negative 9x at that, and negative 8x for the inside terms, and sure enough we got it, negative 17x. It worked out. So we got it on the first try there. So we have 3x minus 8, and over here we've got an x minus 3. So again, lots of different options. And the way I always look at it is thinking of numbers. I want to multiply the 3 by something that's going to give me something smaller than 17 because I knew the two numbers had to add. That's why I didn't want to multiply the 3 by the 8 first. I knew that wouldn't work because 8 times 3 makes 24. It's too big. And see, even 3 times the 6, if I did that, that would make something too big. And so some of those I could think about and, oh, I don't want to do that because it makes it too big. I won't even try the whole thing. I just try something that might end up working. And the 3 times 3 made 9, and I knew that was smaller than 17. So as long as the next one was smaller than 17, they added to make 17, we'd come up with the right answer. Well, taking a look at the next problem, here we have a negative sign in front of the last term. So these are a little bit tougher because now they're subtracting. Outside terms and inside terms are subtracting to make 9x. And it's always more difficult to subtract than to add, so that's why I think it's a little tougher. Also, what makes it tougher is we don't know where the sign goes right away. We do know we have a 5x and an x because 5x and x are the only numbers that make that 5x squared. So now we just have to try the different numbers that multiply to make 18. Now remember, we want one number to be bigger than 9 and one number to be smaller so that they'll subtract to make 9. So my thinking is that I need to multiply 5 by a number that's going to give me something bigger than 9. And it has to be big enough. I don't want to get like a 10 because 10 minus 1 is the only thing that's going to end up giving me 9. So I'm going to try something a little bigger. So my guess is 6 and 3 because 3 times by 5 makes 15. But if that doesn't work, I got to try the other different ways we can multiply to make 18. So that would also be a 3 and a 6. We have a 2 and a 9, 9 and a 2, and we have a 1 and an 18, and an 18 and 1. So not as many options here, but let's try this one. 6 and 3. Again, I wanted to get 5 being multiplied by something that would make something bigger than 9. So this does, 15x, that's good. And then here I have 6x, and that will subtract to make 9. So now I got to subtract to make 9. Now we want to make a positive 9. So in order to make a positive, I need more positives than negatives. So minus sign goes with the 6, plus sign goes with the 3. And that would be our answer. So 5x minus 6, and we have a x plus 3. Well, let's try another one here. Here we have, this time it's a little different because we have the prime number as the last term. So sometimes you see that. So again, the outside terms and inside terms are subtracting because they're opposite in sign, making a negative 5. But they subtract to make 17x. So let's try this. We know it's going to be 1 and 5. That's all we know. We don't know where the sign goes yet. But we do know that the last term, or the first terms, need to multiply to make 12x squared. And we need to multiply something to make, well, we need to probably multiply the 12 or the 5 by something to make something bigger than 17. That's my guess. So as I think about that, okay, think of the factors of 12. I don't want to multiply 5 by 6. See, if I multiply 5 by 6, 6 times 2 makes 12, but 5 times 6 makes 30, and that's really big compared to 17. So I'm not going to try that first. I want to multiply 5 by something smaller. And see, 5 times by 4 Well, that might end up working. So let's try this. Let's try 4 and 3. If it doesn't work, we'll set up some other ones. So let's try 4x and 3x. You see, 4 times by 5 gives me something close to 17, but bigger. See, 4 times by 5 gives me 20x. 1 and 3x gives me 3x. Those subtract to make 17x. It works. So in order to get a positive 17, I need more positives than negatives. So the minus sign has to go here to make a negative 3x. The plus sign goes with the 5 to make it a positive 20x. And that does end up working. So 4x minus 1 and a 3x plus 5. So again, my strategy is to look to see if I can find what numbers, first of all, that if the outside and inside terms add or subtract, but if they do subtract, I want one of the numbers, one of either the outside or inside terms, to multiply to make something bigger than that middle term. See, the same thing happens on this one here. Here we have a negative 10, so I know outer and inner are subtracting to make a negative 3. That means they're only 3 apart. So when I think about it, I know it goes 7x and x. So I think 7 times a number. Well, 7 times like 5 is going to give me 35. That's too big. Even 7 times 2 gives me 14. So that might end up working. I could put a 5 and a 2. Let's see if it does. 2 and 5. Well, when I do this, though, that makes 14. This makes 5. Oh, I need it to be closer together. Those numbers are 9 apart, so I know that's not right. So I've tried that, so I'm not going to erase the 5 and 2 that I wrote to the right-hand side of the problem because I don't want to try that again. So I'm going to go ahead and just cross that out and try something else. Well, let's try this. I don't want to multiply 7 by 10, but if we multiply 7 by 1, let's see what happens. Let's put the 1 here and the 10 here. See, here we get 10x. 7 times 1 makes 7. Those numbers are 3 apart. That works. So we found it. Now we just want to make it a negative 3. In order for it to be a negative 3, we need more negatives than positives. So 10 needs to be negative. The 7x needs to be a positive. So we'll put the plus sign with the 1. And then we have it. And so the nice thing about this method is it puts it in the answer form right away. And it also, we can check our work as we go. Checking the inside-outside terms, and we know the first and last terms multiply to make those values because that's why we picked them. So those are some problems that you'll see on tonight's homework. Good luck.